today. Today questions we have binary tree maximum path sum, in which we will see that a path is a binary tree. A path is a binary tree is a sequence of nodes where each node of the adjacent nodes in the sequence has a connecting them. So a node can only appear in a sequence at most. Note that the path does not need to pass all through the road, right? The path sum of a path is the path is the sum of nodes value in the path, right? Like if this is the example, right? Let's see if this is the example in which we have root node 1 and child is 2 and 3. Then if I'll consider this is the path, right? If this is the path, so what will happen? It will first count 2, then 3, and then what? 3 means 2 plus 1 plus 3. So this is the path sum because we are moving like this only, right? We are moving like this only. From 2, 1 and 3 we are coming. So this is the path, right? So path sum is what? Right. So this is the path sum, okay? And this is the path. So sum of nodes value in the path, right? So given the root of the binary tree, we have given root of the binary tree, and we have to return the maximum path of the any non-empty path. Means we have to choose the path and we have to return the maximum sum path sum. Okay, let's turn to so we have another another example in which we have to see that this is the node, right? Root node given, this is left, right, and its children 7 and 5. But if I'll go this path, right? If I'll go this path, then what happened? We have 15 plus 20, then 7, right? This will be the maximum path, right? And it will come around 42. Okay, so now I think you have understood. We are not considering any other path because we will not get the maximum path sum. So if we consider for the overview of this program, what programming is saying. So in this problem, we are given the root of binary tree, right? And we want to find what maximum path sum of this tree, correct? So before we delve into the solution, let's first understand few terms, right? A path is a continuous sequence of node, correct? Which is connected to each other. So there will always be at least one node in a path, except for the starting and the ending nodes. Every node is connected to other node in the sequence, correct? Every node. So these two nodes, right? These two nodes either be connected to either could be children, that can be children, and or one of them could be a child, right? And other node could be a parent node, correct? So these are the possibilities. Okay, so in other words, what we can say, no node can have more than two conditions in the sequence, right? And each node contain a value, what? Each node contain a value which could be negative, 0, or a positive. Okay, only these two conditions should have. In which if I'll go in the representation, we can see that if we have 2 minus 3, 5, 2 minus 1 minus 1 and 2. So if we'll consider this path, right, and let me see, this path, right, for this node, so what will happen? Wait 1 minute. For this path, okay, so what will happen? We have 2 now, then we have 3, and then we have what? Minus 2, right? So the path can be what? Will come from 2, 3 and minus 2, or either if we'll consider this path, right, for this node, there can be this path also, right? We can move like this also, right? Or sorry, and another path can be what? 4, 5. There can be this path and this path, right? Like this, you can say this path. So this is an example of different path in the binary tree. Okay, we have tree, we have different path, and there can be a multiple path also. But if we'll consider this -3 -1, right? We will consider this -3 and what? -3 and 1, right? Then this is not path. 5 and 1, this is not path. -2, 5, 1, this is not the path. This is not path because -1, -3, 5 and 1 don't form a sequence, right? This is not forming the sequence. If this will go like this, right, then this can be, but this is not forming the sentence like this. This is not the sequence, it is breaking here. And if we consider for this node, this is not the path because 5 is not connected to 3 node. These 3 nodes is not connected, right? So these things you have to understood, right? Now coming to point in which we can say that a path sum is the sum of value of all the node in the path, all the node in the path. If we are considering a path sum, so the sum of the value of all the node is what? All the node in a path. Okay, because the value could be what? Negative, positive, right? A path sum could also be a negative or positive, correct? If value is negative, positive, so path is also negative and positive. So every combination of two nodes in a tree can form a path. Every node, every combination of two nodes can form a path by using sequence of all nodes. In fact, every node in itself can also be considered a path, correct? Because every two node we are talking about. So a path needs at least one node. So we can see that the number of paths could be pretty large, right? There can be multiple paths, right? And there would be many path sums, because if there is many paths, then sum of paths is also many, right? Path sum is also many as the number of paths increases. So we need to find what? Maximum path sum, right? So if we'll consider this one, right, this path, right? If we'll consider like this and it will move like this, so what will happen? We have 1, 5, 2 in this, and we have what? 8, and that is our maximum path. So what it is saying that we must traverse the entire tree to find the maximum path sum. Second, we are interested in a set of nodes that form a continuous sequence, that is called path. And third, when traversing trees, we prefer DFS over BFS because it can examine each path before moving on to the next, right? So we will prefer DFS. So the approach is what? Post order DFS. We will make DFS algorithm here and we will traverse for all the nodes and we will calculate all the paths. So the intuition behind the approach is, one way to find the maximum path sum would be to look at all possible path, correct? Calculate their sum and then find maximum path sum. However, this would be a brute force approach, correct? If there are n nodes in the tree, creating all path and computing their path sum would take what? O(n) square. We can do better than this, considering a scenario where the path with the highest sum passes through tree root. Okay, there could be 4 possibilities. The first possibility is the path start at the root. The path start at root and goes down to the root left child, and goes down to the what? Root's left child. And we don't know how long the path is, but it could extend the bottom of the left subtree. Correct? It will extend to the bottom of the left subtree. Second possibility is that the path start at the root and goes down to the right child, right child. Once root's left child and once root's right child at the bottom. Okay, so very similar to previous case, but direction is toward right. And the third possibility is the path involves both left and right child. Path involves both left and right child. The path does not involve any children. The path in the fourth possibility, in which we will see that path does not involve any children, right? And the root itself is the only element of the path, and root itself only element of the path with maximum sum. Correct? So in this we can get highest sum that is passes through the root, and we have the 4 possibilities in which the path start at the root and goes down to the root's left children, right? And similarly, possibility second is to the root's right children, and third, in which we will involve both children, right and left, and fourth will be we are not going to any child, only we will consider the root that have the maximum value for the path sum. So if we consider this program, so we can see that the maximum path start at the root and it goes down via left child or of the root, right? So we know that there will be root always, right? There is a root. So possibility is what? We can move left or right, or we will move what? With the left and right. And third possibility is what? Fourth is what? This one. So now if we'll consider we are going to left children. So left we have no right. So either we can go here or here. The possibility is always two. Either we can go this one or either we will go this one, right? So algorithm will traverse for all the nodes, correct? So in this case, what happened? We will first move what? Left. Then we will go to the left, but we will not find maximum. So we'll check for the right, and we find that it has also a children, right? When it's moving to right. So in this direction, first it start left, then right, then left, right? And we will have the maximum path sum what? 9 with 2 plus 5 plus minus 2 plus 4. And that will get path sum is 9. In the second, we will see that the maximum paths start at the root and it goes down via the right child of the root, right? So the maximum path start at the root, right here, and it goes down via the right children, right? And then it can go here or here, but it finds here in the left side, right? So but it starts from what? It's right, not left. And then it finds that the maximum path sum is what? Path sum you can say is 8. So another possibility is what? the maximum path sum with root, and that involves left and right, because this is the left, right, and this is the right for whom, for this root, correct? This is left and this is right, okay, and this is what, root. So left children is also here and right children is also here. This can be this or this, right? This can be this or this, but in this we have the maximum path sum, correct? And that involves both children. So this is the third possibilities. And when it comes to the last one, in which we have the maximum path sum with the root doesn't involve any children, and we have what, maximum path is what, 3, right? So these are the 4 possibilities in which we have seen this, right? Like how the algorithm will works. So now we know that the path contains the root, right? What we know? We know that the path contains root almost in all the cases. So therefore, in the beginning, we can assume that path sum is the root node's value. Path sum is the root's node's value in the beginning, correct? And then to find the maximum path, we determined if there is a viable path leading down through the root's right subtree, right? Right, you can say right subtree. So what is saying, we will to find the maximum path sum, we determine if there is a viable path leading down through right subtree. So please note that remember that a node can have negative or a positive value. So the path sum contributed by the subtree would also be a negative or positive. It would make sense to consider a path sum contributed by subtree only if it is a what, positive. Otherwise it will give what, negative, right? It will reduce the maximum path. And so if not, we can safely ignore it. If that is going negative, what we can do, we can safely ignore it, right? If it is going to do minus, right? In other words, the path does go down to the left or right subtree only if we see again in the path sum. If we are seeing that there is a benefit of going in the left or right, then only if we see again in the path sum, correct? Otherwise no need to go left or right subtree. This means that we must first determine the gain, correct? Before moving to left or right subtree, we have to first determine the gain, the benefit in the path sum. If there is no benefit if there is no benefit in the path sum which is contributed by the left or right subtree, there is no need to go left or right subtree. Once we have both, we have decided whether to include their contribution. We can see that we need to process the children before we proceed a node, correct? This indicates that we need to perform what? Post order traversal of the tree. Got it? Right? We have to perform a post order traversal of a tree, because in post order children are processed before the parent, correct? Children are processed before parent. And so to implement post order traversal, we implement a recursive function. What we'll do? We will do a recursive function to implement post order traversal, and that we know already, right? So this function takes the root of subtree. This function takes the root of subtree as the input. Correct? Root of the subtree. The function return the path sum gain contributed by the subtree. Right? What will happen? The function will take the root of subtree, and it will return the maximum gain, or you can say the path sum gain. It is going to gain in the path sum or not, that will return as a gain. To calculate the path sum gain, the function call itself recursively on the subtree left or right child. Understood? What we have to do? We know that the path contains always root, right? And therefore, in the beginning, we can assume that the path sum is root node value, right? And to find the maximum path sum, we have to see the viable path is through going to the down is correct or not. That will giving you negative value, positive value, that is adding some contribution in the addition to the path sum. There is not reducing the value, right? The gain should be here. And so that we have understood that we should use post order traversal, and the post order traversal we will implement a recursive function, and that function will take the root of subtree, and the function will return what? The gain, the path sum gain. And to calculate that, we have to do it recursively for the left and right child, correct? Which is giving benefit. So we will consider the scenario where the maximum sum path passes through the root. But if it doesn't, so if this is the example, right? If this is a example, so you can see that the path with the maximum sum does not pass through the root, right? In this, we are only going through what? This one, right? We are not considering the path, this root, right? We are not going here. We are not going with this root. In this maximum path, we will get what? 32, and that is correct. So we have to consider the scenario, okay? So we slightly tweak our algorithm, right? What we have to do? We tweak our algorithm to include the case when the path does not passes through the root, right? Till now we have understood for what? To the path sum that is going through the root. But now we have to little change our algorithm, right? And we have to include a case when the path sum does not passes through the root, but that is giving maximum value, right? That we have seen now. Now in addition to returning the path sum gain contributed by subtree, the recursive function also keeps track of maximum path sum, right? The recursive function also keep track of what? Maximum path sum. We update the maximum path sum whenever we find a new maximum. So let's put this formally now. So let's see, this is the recursive function gain from subtree, and it takes the root of subtree as an input, right? That we already knows. So this is a recursive function. So the function has two possibilities, right? The function has two possibilities now. The first, the function return the path sum gain contributed by the subtree, right? The function will return what? Path sum gain contributed by the subtree. The path sum gain contributed by the subtree can be derived from a path that include at most one children of the root, right? The path sum gain contributed by the subtree can be derived from a path that include at most one child of the root. Or you may wonder, why can't we include both children, right? If we include both children in a path, the path would have to make a fork at the root. The root is already connected to its parent. The root is already connected to its parent. Now, if we include both children as well with 3 connections, it wouldn't be valid path anymore, right? If we consider both children, if we include both children as well with the 3 connections, right? With the 3 connections, it wouldn't be a valid path anymore. Therefore, we can say that the path consists of at most one child of the root, either left or right. So the recursive function compares left again, right again, correct, and adds maximum of 2 to the value of the root, right? There is root and there is 2 possibility, either go left or right, right? And again this came and this came, right? Which one is maximum? We will add with the root, either with the root left or either with the right, right? The sum gained from the subtree is then returned to the caller. The sum gained from the subtree is then returned to the caller. How? We will calculate left again, right again. Now we will have what? We have to find maximum between these two plus root, and that will call what? Gain from the subtree, right? We will have now maximum, and from the maximum we will add to root, and that is called gain from the max, right? Gain from the subtree. So we will use max of gain left and gain from the left subtree hyphen 0, because we want to consider the gain only if it's positive. If it's negative, we ignore it or consider it as a 0. This function keeps tracks of maximum path sum. So assuming that the maximum path sum passes through the root of the subtree, as explained earlier, we consider all possibilities now. The path goes through the left subtree and the path goes through the right subtree, right? The path goes through both left and right subtree. The path doesn't involve left or right subtree. So these are the 4 possibilities that we have already discussed, right? 4 possibilities that we have already discussed, right? The first one is what? Path goes through the left subtree, path goes through the right subtree, path goes through both left and right, and fourth, path doesn't involve left or right, right? So we include the left and right again if they are positive and the value of the root node. So we compare this sum with the current maximum path sum and update if necessary. The following code segment takes the care of our 4 possibilities, right? What we have max path, left again plus right again plus root, correct, and then this is called what? Maximum path gain. Okay, maximum path gain. I think you have understood now. So if we'll talk about the algorithm, right? If we'll talk about the algorithm, the main functionality is the main function of the body of the algorithm is what? We have to initialize a global variable that is called max sum to infinity, right? Infinity, and then call the function gain from the subtree on the tree's root, and then we will return what? Max sum, right? This should be the main function body. Now body of the recursive function, right? That is called gain from the subtree, right? This is the gain from the subtree. It accepts the root of the subtree as an input, right? So first, if the root is null, we'll return 0. This is the base case, and it doesn't, if a node doesn't have a left or right child, then the path sum contributed by the respective subtree is 0, correct? Then call the function recursively on the left and right child of the root and store the result into gain from left and gain from right respectively. And third, if either is negative, set to 0. This is because we don't want to include path sum contributed by subtree if it is negative. And fourth, if we will update maximum path sum, maxsum seen so far. To do so, compare maxsum with the sum of following. Update it if it's smaller. The value of the root itself, gain from left, gain from right, right? If it is negative, we will put 0. Otherwise, we will add, right? We will update. And the fifth, return the path sum gain contributed by the subtree, the maximum of the following two value, gain from the left and gain from the right. With the, we will do plus with the root, right? We will do plus with the root, plus with the root, right? And we will return the path sum, right? We will do return the path again. A note on the base case. Let's say our recursive algorithm does not algorithm reaches a node with no children. Because there is no left child, our path cannot go forward the left subtree. In other words, the gain from the left subtree is 0. So when function call on the non-existing children of the node, it returns 0. This would be true for the non-existing right child as well. Therefore, we can safely say that base case is when the root is null. Correct? So if we consider -2 as a root, right? The max sum is what? Infinity. And we have what? We have current is what? At root -2. If we'll consider now max sum infinity is what? Max infinity, right? And current root is what? Now 3. We are going to left, right? We have come to here, the left, right? Still, we have maximum infinity, that max sum, right? Now, from here we came to what? Left, right? We came to left, this path. Now, there is no children, right? For this one, as you can see here. There is no children, means coming from here and here, the value the gain will return as a what? 0, right? This is called base case. For leaf node, the children returns what? 0. And so the maximum of what? 2, 2, 0 and 0, right? So this will be what? 0. And then we have infinity, right? So from this part, what we are getting? We are getting minus, we are getting 2. So now the max sum is for 3, we have what? 2. So return the maximum of 2 plus O and 2 plus O, right? Next we have max sum 2 and we have current root would what? -1, correct? We are coming to this node. It is returning 2 with this and this, right? We have got maximum 2 here. And now it is also giving 0 and 0, right? So for leaf node, children returns what? 0. Now we are considering we have 2 and we have -1 for this node, right? Because if we'll consider for this one, right, and we have passed this node, right, what we got? We have got return -1, right, as a here you can see that. So still the maximum sum is 2, and there is no need to do any change, because no need to change in the max sum, because max sum is greater than 3 plus 2 plus O equal to -1, right? Now coming to here, we can see that it was giving 2, it was giving -1, it was giving with what? -1. We have did add all this add, right? we did these two, -3 or -1, right? And we have written what? -1. Now return maximum of -3, 2 and -3 plus -1, right? So it will return -1. Now we are coming to root. Current root is what? 5 here. So we will see here that if we'll consider the left child going, current root is what? 1, and that's why it doesn't have children, so it will return 0 0 as its return, and it will return 1. Now we'll consider to the root 2, and similarly we will return 0 0 as children, but it will return 2. So it is returning 2, it is returning 1. And now we have to update the maximum, right? 5 left, right. This is the left again, this is the right again. So total maximum is what? 8. We have updated the maximum. Gain from the left is 1 and gain from the right is 2. So total is what? 8. So it is greater than the current maximum sum, that is 2, that was 2. So we have to update this one. Now if we'll consider this -2. So now it is returning the whole value what? 7, right? Because this is giving the value 2, 1 and 8, right? So we are not considering this one. We are not considering this one. We are considering this path, right? And in this you will see that we will return 5, 1, 6 and 5 plus 2, 7, right? We will return the greater of these two. So here we are getting 6, in this we are getting 6, and in this we are getting what? 7. So it will do addition, right? -2 0 -2 0 7 equal to what? 5, and 5 is less than 8, correct? 5 is less than 8. We are considering we are getting from what? This is the root value, that is -2. We are not considering this path, that is taking 0, and this is 7. It is coming from here. I am taking as 0 from here. Here we are taking what? 7, and this is already -2, right? And which is equal to what? 5. So which is less than 8, and so we don't update the max. So still we have max 8 because we don't have more than this. So we have completed post order traverse of the tree, and we have seen that the max path sum is what? 8. That we gone from what? From here, right? From here we have got from here max path sum. Now coming to finally at the code, right? You can see that we are taking as an input root, so we will take infinite value of the maximum, very minimum value we will take of the integer, and then we have to make a recursive function gain from the subtree, and it will take as a root, and we have to update maximum in this function, and it will return maximum. So if we are talking about we have maximum here, right? Maximum, and in the private we have a function. This function is here now, right? So this is the post order traversal of the subtree rooted at root, right? Now this is the base case. If children doesn't have, then it means it will return 0. The root is null, will return 0. And if not, add the path sum from the left subtree. Note that if the path sum is negative, we can ignore it or count it as 0. This is the reason we use math.max here. And what we have? Gain from the left and the 0. If this is not negative, this is positive, we will store the gain from the left. Similarly, if this is a positive, right, we will return gain from the right. If this is negative, we'll consider as 0. If not, that the value. Now we will take maxsum function, and that function will take maxsum max gain from the left plus gain from the right, that will give, and the root value, right? This is the function, right? And in which we will have the whole value, root, left, left again, right again, and root value, and the sum, the previous sum value. And if this is greater, we will update the maximum, or if this is not the greater, we will not update, right? And finally we will return gain from left plus root, and gain from right plus root, right? And this function will update, will give you the gain from the subtree, right? And that's why this is called post order DFS, right? Because we are calculating the maximum first, and then after we are returning the gain from the subtree, right? And in this case, what we have, we will return the time complexity is what, on, and space is also on, because we have to traverse each node, right? We have to visit each node. And similarly, we don't use any auxiliary data structure, and but the recursive call will keep on deep as a tree height, right? And in this worst case, the tree is a linked list, and so if the height is n, then there the space will be what, O of n square, right? I think you have understood. So let's recap the program, right? So we will take maximum, and then the recursive function is gain from the subtree, line number 20, and then we will implement at line number 27, in which we will take the root, and if the root is null, we will return 0. If not, we will return gain from left, gain from right, and the maximum we will update from the maximum. And finally, if this is not the case, if that is not getting maximum, right, we will not update. If we will getting left plus right plus root value is more than the maximum, then we will update at line number 42, and this will be remain maximum till will not get gain from left plus gain from right plus root value as a maximum, right? And finally, at the line number 45, it will recursively calculate all the gain from subtree value, from gain from left plus root value, gain from right plus root value. Which one is best, it will return as a gain from the subtree. So thank you guys. If you have any doubt here, please ping me in the comment box, and thank you for here with the 42 minutes we have discussed now. So please like, share, and subscribe Expert Funda if you like this. Thank you so much.